Back to another video of Daishinfinity. In this topic, we're going to talk about the linear operators of the differential quotient. If you don't know what a differential quotient is, it is just the limit as h approaches 0 of f of x plus h minus f of x divided by h. So in this video, we're going to prove some of the theorems we have for the differential quotient, such as the sum rule, sum of the two different function rule, or the multiplication with a factor, the factor rule, or some kind of other elements. So since you know, or if you don't know, the differential quotient is just a basic formula for, that was derived from Isaac Newton and Gottfried Leibniz, which states that a functional derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So if we look at this graph, we have the x naught and an x naught plus h. So the x naught is a specific point on the x-axis. It's a real number, and the h is going to be an additive number which will suddenly approach 0. So if we have these 2 points, we would have a thing called a secant line, which will surpass the function at 2 intersections. So it will have 2 intersections, but if h is approaching 0, then the secant will approach a tangent line, and the tangent line will touch a specific point on the curve, which is going to be x naught and f of x naught. So if we let h approach 0, it means that we can find the derivative or the gradient of the line at a specific point x naught. Now the interesting thing is to somehow prove the addition formula. So if I have some kind of function f of x and I want to add it with another function g of x and take the derivative, it states that in the math books that it's the derivative of the first function plus the derivative of the second. Now I'm going to prove this one, so let's make a proof. The proof is going to be pretty simple. We're just going to take the limit as h approaches 0 of f of x plus h plus g of x plus h. Since we have 2 functions, we also have to apply it for the g of x, minus f of x minus g of x, all divided by h. Now if you look at the components of this fraction, we can look at the f of x plus h and the minus f of x. We can also compare it with the g of x plus h minus g of x, and since we have a fraction, we can split this up into 2. So we have the limit as h approaches 0 of f of x plus h minus f of x divided by h plus g of x plus h minus g of x divided by h. Now we have a limit of those 2 sums, and I'm going to prove that the limit of 2 sums can be the individual limit of the sums. But since we have this theorem, we can apply the limits on these 2. So we have the limit as h approaches 0 of f of x plus h minus f of x divided by h plus the limit as h approaches 0 of g of x plus h minus g of x divided by h. Now this is just going to be the definition of the derivative of f, and this is just going to be the definition of the derivative of g. So now we finally proven that it's just the derivative of x, f of x, and the derivative of g of x. So now we have proven the first formula. Now for the second one, I would like to talk about the factor rule. It states that for k element any real number, we can say that k times f of x And when we take the derivative, it's k times the derivative of x, f of x. So I'm going to prove this one. The proof is going to be pretty simple. It's just going to be the limit as h approaches 0 of k times f of x plus h minus k times f of x divided by h. Now since we have k on both sides, here and here, we can factor the k out, leaving us with the formal derivative, so we can have k times f of x plus h minus f of x divided by h. And this is also another limit theorem, so if we have a number before the limit, we can pull the limit outside. I'm going to prove that one too in another video. So it's going to be k times the limit as h approaches 0 of the definition of the derivative of f of x. Since we have the definition, we can say this is f prime of x, leaving us with k times f prime of x, leaving us with another proof which has been confirmed. So we have already proven two things of the differential quotient, the sum of the two different kinds of functions, f and g. If we would take the derivative of it, it will be the individual derivatives of them. And then number two, we have a factor k for k element real numbers. K times f is going to be k times the derivative of f. Now for the homework, since we didn't really do the minus sign, so we didn't do the subtraction of the two functions, I would like you to work on f minus g in brackets prime, that this will be equal to f prime minus g prime. You just use the same rule as the number 1. So in the next video, we're going to prove some of the other components and theorems that should be proven. For example, the quotient rule f divided by g, or the multiplication of two functions, or like somewhat composed functions, such as f composed with g prime. So yeah, we also have many more stuff to show and prove, so I'm very excited to show the ideas and the proofs to you guys, and the approach I do. And if you have any approaches, tell me in the comments. Please like and subscribe to my channel, and we'll see us in the next Daishinfinity video. See ya.